So now we're looking at finding the least common denominator for rational expressions. The first step is we want to factor each denominator completely, and then we can line up the factors just like we did previously when we were doing prime factorizations. The difference is that most often our factors now will end up being binomials. So we have x squared minus x minus 12. Now factored, what is that? What two numbers multiply to negative 12 that add to negative x? Well, that would be x minus 4 and x plus 3. So we'll start over here, x minus 4. And then you might want to leave some space because there might be other common factors, but I'm going to write this right here for now. This is x plus 3. And then we have x squared minus 16. That's a difference of squares, x minus 4 squared, x squared minus 4 squared. So we have x minus 4 times x plus 4. So now we're looking for what is each one of these missing that the other one has. Notice that if we bring down each of the columns, so we need to bring down all of them to get the least common denominator. So our least common denominator is going to be x minus 4. So LCD equals x minus 4 times x plus 3 times x plus 4. And that's because x squared minus 16 is missing the x plus 3, and x squared minus x minus 12 is missing the x plus 4. And recognizing what it's missing is important for our next step. Our next step, we multiply by what it's missing. We multiply the numerator and denominator by what the expression is missing. So if we look at this, let's write down what we have. We have 2 over x squared minus x minus 12. But we know that I'm going to write this a little bit differently than what they did in the example in the lesson prior to this. I'm going to write this in its factored form. So 2 over, when we factored it, we had x minus 4 times x plus 3, and then we multiply times what it's missing. So what is it missing? If we look back over here, it's missing x plus 4 from our LCD. We have x minus 4, we have x plus 3, we're missing x plus 4. So we multiply x plus 4 over x plus 4, which gives us 2 times x plus 4 over our least common denominator. X minus 4 times x plus 3 times x plus 4. Now technically, it says rewrite them as equivalent expressions with the LCD. That technically is written as an equivalent expression with the LCD. We can go ahead, however, and multiply through in the denominator, or in the numerator rather. So this is going to end up being 2x plus 8 over our least common denominator, x minus 4 times x plus 3 times x plus 4. Now we repeat the process with our second rational expression. We have 1 over x squared, let me move that down just a little bit, 1 over x squared minus 16, that equals 1 over x minus 4 times x plus 4. Now what is it missing from our LCD? If we look at our LCD, it's missing the x plus 3. So we multiply both the numerator and denominator by x plus 3. So x plus 3 over x plus 3, which equals x plus 3 over our LCD, x minus 4 times x plus 3 times x plus 4. So our first rational expression written over the least common denominator is 2x plus 8 over x minus 4 times x plus 3 times x plus 4. And our second rational expression over the same least common denominator is x plus 3 over x minus 4 times x plus 3 times x plus 4.